Hey guys, Mr. Jenkins here. This is going to be the first lesson of chapter 4. I think we only cover 3 or 4 lessons in this chapter, so it's going to come and go pretty quick. You know, we'll be studying for the chapter 4 test before you know it. So stay on the ball like we talked about in class yesterday. This is about kind of just interpreting graphs, really. The official title of the lesson is Using Graphs to Relate to Quantities. And this chapter is all about functions. All right, so sorry, your learning target, I don't know why this won't go away. There you go. Your learning target is we want to be able to represent mathematical relationships using graphs. Really, more so, we want to be able to interpret graphs to describe a relationship. Okay, that is actually a little more fitting. Okay, analyzing the graph. It says the graph shows Malachi's cell phone bill for the month of June. What are the variables? Describe how the variables are related at various points on the graph. Okay, so the first thing you want to do is identify, you know, any changes in behavior. Okay, so here's the function as it goes. It's consistent right here, and then it changes. Okay, so we kind of have 2 intervals here. We'll call it interval 1 and interval 2. All right, so in interval 1, you always kind of think about it this way. As x increases, what's happening to y? Right, so as we move to the right, what's happening to y? It's staying flat. All right, so in interval 1, as x increases, sorry, make it a little simpler. As x increases, y remains constant. Okay, so what we actually call that is a constant interval. Okay, if we're thinking about a slope of a line, that'd be a 0 slope. All right, constant means a 0 slope. In interval 2, as x increases, you always kind of start out your thoughts that way as we move to the right on the graph. So from here to here, as we move this way, what's happening to y? Well, the y value started here, it ended here, so it increased. So we would say that the function in that part is increasing. They always try to do some real world tie-in here, so kind of think about what's happening. It looks like, you know, Malachi gets this many minutes of calls for free, and after that, it's a constant rate of something per minute. Okay, so here he had all his minutes. That used to be a thing with cell phones. You had X amount of minutes, and then after that, it started to cost. So that's kind of what we're looking at there. The big thing, though, is that you can see that interval 1 is constant, interval 2 is increasing. Letter B here. So here you would have, if you think interval by interval, there's a lot going on. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 changes in direction, right? But you can kind of put them. You can kind of simplify it, right? So let's just say we're going to look for where is it increasing. Where is it decreasing? And where is it constant? All right, so it's going to be increasing where when I move from left to right, we're going uphill, right? So it's going to be increasing here, 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 and that's it. We're going uphill in this interval from here to here, and then from here to here. That's where we're going uphill. Actually, let me, just to make this easier to tell what I'm doing. Let me kind of redo how I'm structuring this problem. So let me just number each interval. So we'll call this. We'll just go in order. So this is interval 1, 2, 3, 4, 5, 6, 7, 8, and 9. So our increasing intervals were 1, 3, and 5. Our decreasing intervals is where are we going downhill from left to right. Okay, so that would be this guy and this guy, a negative slope line. Okay, increasing is positive slope line, decreasing is a negative slope line. So that'd be in intervals 7 and 9. And then where are we constant? That's a flat slope, a zero slope. So 2, 4, 6, and 8. Who do we appreciate? All right, and then the real world tie-in says, what are we doing? We're showing distance from home or distance from the store. So it looks like in this interval right here, from here basically to here, this person is driving away from the store. Here the person is probably delivering the groceries if we read through the problem. And in this interval, the person is driving back with 1 stop. Okay. All right. So looking at example C here. Actually, I'll let you guys think about C. It says the graphs below relate the height of the water to the volume of the water in each container. So you're thinking about as we filled each container, how would the height of the water go into each one? Okay. So this is where you kind of apply what you've learned a little bit. So you're thinking as the volume of water increases, okay, how is the height of the water going to be off the ground? Okay, those are answered in the notes. So in the filled out notes, I would say you always try to do them and then check them that way. All right, so now matching a table and a graph. This one is really difficult to see. Let's see if I can make that any bigger. I can't, unfortunately. You may want to pull out the notes for this one. I'll try to read it. It says the table shows the amount. Basically, I can't really read that, so we're just gonna talk about how to match this table to its graph. Okay. So remember that these are going to be X values and these are going to be Y values if you ever have a horizontal table, right? The issue is going to be here, though, there are no numbers on our graphs, okay? So we're going to kind of look for a trend. So as X increases from 0 to 3, looks like Y decreases from 5 to 4.4, all right? So we're looking for a decreasing interval, and it looks like that's decreasing, and that's decreasing. So that fact didn't really help us, so we got to dig a little deeper and just kind of figure it out. So I said it decreases from 5 to 4.4. And it also, you might notice, it goes 5, 4.8, 4.6, 4.4. So it kind of has that linear pattern, right? So A goes all the way down to 0. B is not linear. It's got to be C, right? So that's kind of just some things we look at to analyze a graph. And then the last one, we actually have to draw our own graph here, okay? So this is where you kind of tie it all together. A says, suppose you start to swing yourself on a playground swing. You move back and forth and swing higher in the air. Then you slowly swing to a stop. What sketch of a graph could represent how your height from the ground might change over time? Label each section. Okay, so your height off of the ground. So the first thing you would think is, if I'm starting here, would I be on the ground? That might be where most people would start from. But if you're sitting on a swing, you know, your height is going to be a little bit off of the ground, right? So let's start from like there, okay? So think about as you do that first kick back to get going, your height is going to increase, right? And then your gravity is going to bring you back down. And you're going to come back to the same level. You're going to go, now you're going to go forward, but a little bit higher, right? You're gaining momentum. You come back down every time. Now you're going backwards again, but you're going to go higher, right? So you kind of see the pattern. Now forwards again, but higher. Okay, so that type of pattern, and then you would probably do more swings. That represents 2 full swings right there. But we'll go ahead and start the slowdown. Okay, if we slow down, then we're going to gradually kind of see the reverse of this. The next one, be a little shallower. Okay. Or if you were adventurous, you could get creative here. You could say, okay, once I get to the peak, I'm not going to slow down. I'm just gonna jump off. So that would look more like down all the way to the ground, right? Something like that. So, anyways, that's kind of how this one would look. So it kind of says label each part, but I would just break this up and I would just kind of generalize here. Obviously, we could say that's an interval, that, right? We don't want to be that specific here. We would just want to say, kind of divide it right there. So here is where we are gaining, and here is where we are slowing. All right, next one says Emma dives off of a cliff into a lake. The edge of the cliff is 12 meters above the water, and she hits the water 5 meters from the edge of the cliff. Construct a graph below that shows the relationship between the height above the water and her distance in meters from the edge of the cliff. All right, so on this axis, this is distance from the cliff. This axis shows height above the water. So we can assume that where y equals 0, that is the water. Okay, so we know that she starts up above the water, 12 meters above it. So let's just say that's right there. We don't have to label these with numbers, but I will there. And then we also know that she lands 5 meters from the cliff, right? If you jump off of a cliff, you're not going to jump just straight down, right? You want to jump away from the cliff. So that makes sense here. So let's say this. Let's move it in a little bit. Doesn't really matter. The first thing wouldn't have been wrong. I'm just trying to scale it, right? All right, so then you got to decide how would we connect these two, right? Would it just be kind of a linear deal? Would she be going down as fast as the same as she was going out, right? Probably not. She would probably go more like jump out and then kind of start to fall quickly, right? It'd probably look something more like this. She might even go up a little bit and then eventually she's going to go more straight down, right, as gravity kind of takes hold. Okay, so anyways, that's what I have. My notes are a lot more detailed. There's a lot more written on them. Since I gave you verbal descriptions here, I didn't write down nearly as much. I tried to just write down the most important things. And remember, again, from our conversation yesterday in class, okay, you have a Math Excel. Try your best to keep up with these as they come. Okay, that's the best way to kind of be successful. And also, it's the best way to know if you're not understanding something properly or not. Okay, so that is all for this lesson. As always, hopefully this helps. And you guys have a nice day. I guess I'll say one more time that this chapter is going to go quickly. So just try to stay on the ball. Thanks and have a good one.